Well, friends, today we're looking at geometry lesson 21, more logic. So again, you're going to kind of think to yourself, like, is this really geometry? The answer is yes, because logic is really the foundation of every study, right? It's the foundation of math. It's the foundation of, of science, foundation of philosophy. Any type of science where we're pursuing knowledge, we're using deductive and inductive reasoning. And so we've seen inductive reasoning, that's finding patterns, right? But what we're going to talk about today is deductive reasoning. So deductive reasoning is when you have premises and then you get a conclusion. If the premises are true and it's arranged the right way, the premises are arranged the right way, then the conclusion has to be true. Inductive reasoning, you're finding a pattern, and there may be something that shows up next that then disproves the pattern that you're trying to find. Deductive reasoning, on the other hand, provides certainty, or at least as much certainty as the field can give. Right, so not every field is the same kind of certainty as every other field. Right, like mathematical certainty is a different kind of certainty than you can get in science or in philosophy. That and the certainty of the premises that you have. So one example would be, here's kind of the classic example, right? Premise one, all men are mortal. It's here. Premise two, Socrates is a man. Therefore, Socrates is mortal. Oftentimes what we can do is we can take these and make Venn diagrams out of them. So if we imagine this Venn diagram, this is all men, and all men are mortal. So if something is in the category of being a man, it is also in the category of being mortal. And that's true. But we can just take the statement itself. Socrates is a man. So if Socrates is placed here in the category of men, then he has to be also within the circle of being mortal. Okay. And so we have the premises and then the conclusion. The law of detachment. This now we're talking about conditional statements and arranging conditional statements. Law of detachment says this: if the hypothesis in the conditional statement is true, then the conclusion is true. So if P then Q, P therefore Q. By the way, this little symbol here, the little three dots, that means therefore. So if P then Q, P therefore Q. So for example, if an animal is a human, it is rational. This animal is human, therefore it is rational. We can make a Venn diagram for this too, right? So it's saying that if if an animal is human, so we have some animal, uh, and it's human, and if it's human, then it's something that's rational, right? So like this: if an animal is human, then it's rational. Um, by the way, there could be other rational things like angels, divinity, right? These possibilities. So humans are some of the rational things, and then we're saying this animal is human. So this animal happens to be in the human category, and so therefore it's also in the rational category. Uh, and so that's an example of, and this is called the law of detachment, right? So if P then Q, P therefore Q. We're kind of detaching the premise and the conclusion, or the hypothesis and the conclusion. Stating the hypothesis is true, and so we know that the conclusion has to be true. Before we only looked at conditional statements, right? If P then Q. Now we're putting it together in an argument, right? Making several statements together and knowing that the conclusion is true. Another is the law of syllogism. This is when we put two conditionals together, like if P then Q, if Q then R, right? So then what we can do is we can say then if P then R. So in other words, um, when the conclusion of one conditional is the hypothesis of a second. So for example here, right, if P then Q, Q if Q then R. So this is the conclusion of one statement, and then it's the premise or the hypothesis of another statement, right? So that's what we're saying here. The conclusion of the second, R, for example, can replace the conclusion of the first. So if P then Q, so we take R and we just replace it here. That means if P then R. Here it is in symbolic format. P implies Q, Q implies R. That means then, sort of like a transitive property here, P implies R. It's not really the transitive property. It's a different kind of thing. Equality, property of equality. This is an argumentation. It's called the law of syllogism. So one example would be this. If it is a dog, it is a mammal. If it is a mammal, it is an animal. So if it's a dog, it's an animal. Again, this one also can be represented with um, a Venn diagram. Here's if it's a dog, it's a mammal. And if it's a mammal, If it's a mammal, then it's an animal. That means, of course, it has to be the case that if it's a dog, then it is an animal. So that's it. That's the lesson for today. So looking at deductive reasoning, the law of detachment, and the law of syllogism. So we're going to continue to build on this and get into more of what feels like geometry, but applying this as well. So thanks for watching. Don't forget to like and subscribe.